Hello teachers, welcome back to Chapter 5, Section 5-2, Part 2 of the video of multiplication and division of integers. We completed multiplication and division of integers in Part 1 of the video and the models that go along with that, and also with properties. Now I want to spend a little bit of time talking about ordering integers and then order of operations. So definition of less than for integers. For any integers A and B, A is less than B, written as, you know the symbol. Think about this in terms of an alligator. The alligator opens his mouth to the bigger side. So A is a smaller number than B. A is less than B if and only if there exists a positive integer k such that A plus k equals B. In other words, there's got to be some room between A and B if A is truly less than B. It says A is less than B, or equivalently, B is greater than A. They do mean exactly the same thing. Again, if this is the alligator is still open to the bigger number, which is B. If and only if B minus A is equal to a positive integer, that is, B minus A is greater than 0. Now we have a theorem. Okay, this is in 3 parts. So let x, y, and n be any integers. So 3 different integers. If x is less than y and n is any integer, then x plus n is less than y plus n. In other words, we're allowed to add n to both sides of this inequality. So if we start off with x is less than y. Let me get my highlighter working. If we start off with x is less than y, here notice we still have x is less than y. We just added n to both sides. If x is less than y, then negative x is greater than negative y. Watch what happened there. We switched directions. So it's like we multiplied each side by -1. Another way to think about it is we divided each side by -1. Both of those give you negative x and negative y. But when this is less than, if you multiply by -1, that turns into a greater than. And then the third part of the theorem, if x is less than y and n is greater than 0, then you are allowed to multiply by n on both sides. Just like earlier, we divided, or actually we added n on both sides. Now we can multiply as long as n is greater than 0. If n is less than 0, what's going to happen is what happened above. So you can do both of these things in the same step. But if you start with x is less than y, notice we still have that here. X is less than y, but we multiplied both sides by n. And this is true again as long as n is a positive integer. And I said we had 3, but we actually have 4. And this is the one that I was just talking about. If x is less than y and n is less than 0. So again, notice the setup. X is less than y over here. Now we have x and y, but it turned into a greater than. Why? Because n is less than 0. We're multiplying by a negative number. So it's basically combining 2 and 3 together to come up with our fourth property. So whenever you multiply or divide by a negative number on both sides of an inequality, it changes the direction of the inequality. So here we're supposed to use the theorems developed to find all integers x that satisfy the inequality. So we know that x plus 3 is less than -2. Now we could just guess. But if we use the theorem to get the x isolated by itself, we could just subtract 3 on both sides, couldn't we? Or add a -3. So if I've got x plus 3, and I'm going to put a little space, is less than -2, I'm allowed to add a -3 on the left and add the same value, -3, on the right. Now, why in the world would I do such a thing? Well, this positive 3 and this -3 cancel, and that's going to give me x isolated. So I know that x is less than -2 plus a -3 is -5. So any x that I plug into this inequality must be less than negative 5 for it to be true. So for instance, let's just take negative 6. It's less than negative 5, correct? So negative 6 plus 3 is less than negative 2. Is that true or is that false? Well, negative 6 plus 3 is negative 3. Negative 3 is less than negative 2. That's true. And any number less than negative 5 is going to make that inequality true. Now do me a favor, pause the video, and go ahead and solve for this x. It's got an extra step, but go ahead and see if you can do that. All right, here we go. Now, I can write this as negative x minus 3 is less than 5. Notice I left a little space again because I want to get rid of this negative 3. So what am I going to do? I'm going to add 3 and add 3. How did that help us out? Well, this negative 3 and this positive 3 cancel. And now I have the result, negative x is less than 5. But now we need the x by itself, not the negative in front of it. So I can use number 3 of the theorem. Let me go back to number 3 for you real quick. Number 3, if x is less than y and n is greater than 0, then nx is less than ny, or actually number 2, if x is less than y, then the opposite, negative x, is greater than negative y. Let's just use number 2. So what I can say here is change this sign, switch this operation, and change this sign. In other words, x is greater than negative 5. Now the way I like to think about it is we multiplied this side by negative 1, and we multiplied that side by negative 1. And it has the same result. Whenever you multiply both sides by a negative, the inequality switches, and now we know that x is greater than negative 5. Now let's look at the typed up results one at a time. So remember, if x plus 3 is less than negative 2, we can subtract 3 or add a negative 3 to both sides. That's exactly what we did. It's the exact inequality with negative 3 added to both sides. The 3 and the negative 3 cancel, and you get x is less than negative 5. When you look at the second result, again, they recopied it, and then they added positive 3 to both sides of the inequality, which does not change the direction if you add a negative or a positive number. The 3's cancel here, and you get negative x is less than 8. But then we don't need to know anything about negative x. We need to know positive x, which switches from a less than to a greater than, and we get x is greater than negative 8. Now see, we're told if x is less than or equal to negative 2, we're supposed to find the values of 5 minus 3x. All right, let's talk about an unusual problem here. So we have x is less than or equal to negative 2, and they want us to find the values of 5 minus 3x. So we're going to try to build up to this 5 minus 3x. Again, we know that x is less than or equal to negative 2. Let's start here and see if we can turn this side or both sides into the statement 5 minus 3x. So here we go. I need a negative 3 times this x. So I'm starting off here, and I'm going to multiply this x by negative 3. And I'm also going to multiply the other side by negative 3. Okay, so we started off again. Let's highlight. X is less than or equal to negative 2. But now when you multiply by a negative number, what happens is this inequality flips. This has got to switch around. So what I've got written here is not really true, because that has to change directions. So really this statement should say negative 3x is greater than or equal to, and then we know negative 3 times negative 2 is 6. Okay, now notice the difference. Now I have a negative 3x, but over here we have 5 minus 3x. How am I going to get that 5 there? Well, I'm going to add 5 to both sides. So I can say 5 minus 3x is greater than or equal to 5 plus 6. And then I simplify that, and now I've got 5 minus 3x is greater than or equal to 11. So we're supposed to find the values of not x. We know x is less than or equal to negative 2, but we found the values of 5 minus 3x. And if they have to be greater than or equal to 11, then that would be the values 11, 12, 13, 14, that same pattern with my ellipsis marks that goes on forever, and there you go. So that is the set that is 5 minus 3x, as long as x is less than or equal to negative 2. Now let's look at the typed up version. So notice it says if x is less than or equal to negative 2, then negative 3x is greater than or equal to negative 3 times negative 2. Remember, that's the step where we multiplied both sides by negative 3 of what we started with, and that switched the direction of the inequality. Then they simplified it, then they added 5 to both sides. Now when you add or subtract, or add a negative rather, your inequality direction doesn't change. It's only when you multiply by a negative value that the direction of the inequality changes, which gives you 5 plus a negative 3x is greater than or equal to 11, which is the same as 5 minus 3x is greater than or equal to 11. And for the last topic, I want to talk about quickly order of operations on integers. So operations on integers should be performed in the following order. If you ever have grouping symbols, which means parentheses, those should be handled first. If there is more than one grouping symbol, the innermost should be simplified first. Then you should do exponents after you handle the grouping symbols. Then you should do multiplication and division, and that's always from left to right. Whatever comes first from left to right should be handled first. It could be multiplication, it could be division, and then finally the last step is addition and subtraction in the same manner from left to right. If addition comes first on the left, then you do it. If subtraction happened to be first, you would do it. So let's do a few examples where we're using order of operations. Okay, now here we have parentheses. I want you to note that, but there is no work to be done inside the parentheses. These parentheses are actually here to let you know that you're raising negative 2 to the third power. Now, if we write that in an expanded form, that would be negative 2 times negative 2 times negative 2. And we're supposed to do this from left to right. So negative 2 times negative 2 is a positive 4 times negative 2, which is equivalent to negative 8. So we know a positive times a negative is always a negative. What do we know about a negative raised to an odd power? Let's keep that question open and think about that for a minute. Now the next question is negative 2 to the fourth. Very similar, but I'm going to have an extra 2. So negative 2 times negative 2 times negative 2 times another negative 2. Again, we're supposed to work left to right. So negative 2 times negative 2 is 4 times negative 2 times negative 2. That's going to be negative 8 times a negative 2, which is going to give us a negative times a negative. We always know multiplication is positive, and 8 times 2 is 16. Now, if you're still thinking about a negative raised to an odd versus a negative raised to an even power, how about this? When you take a negative number and raise it to an odd exponent, it's always going to be negative, because you're always going to have an extra negative left over when you pair up the negative signs. So the pairs will turn positive with the extra negative left over. On the other hand, when you have an even value, your negatives pair up and will always turn positive. So a negative raised to an even power is a positive, a negative raised to an odd power is a negative. Now you can think about that on this question if you want to, but we really don't want to raise negative 5 to the 15th power. If you recall, we have a property of exponents that when we divide with the same base, and those bases are both negative 5, then we could subtract the exponents. This is equivalent to negative 5 to the 15 minus 12 power, which is negative 5 to the third, which is negative 5 times negative 5 times negative 5. We know that's going to be, that's to an odd power, so the answer is negative. 5 times 5 is 25, times another 5 is 125. What about if we take negative 1 and raise it to the 101st power? Well, that's odd, right? And then when you multiply 1 over and over again, 1 times 1 times 1 times 1 is always 1. So when you take a negative 1 to any odd exponent, the answer is negative 1. Which brings me to the next question. We're taking a negative 1 and raising that to an even exponent. So that's negative 1 to an even power, which is going to have to be a positive 1. Because remember, when it's to an even power, all those negatives pair up and turn positive. Now that's enough for exponents for just a second. Let's talk about the rest of order of operations. Notice there are no grouping symbols here whatsoever. There are no exponents here. You know the rule that multiplication has to come before addition and subtraction. So I need to multiply 7 times 3 first. So I have negative 3 plus 21 subtract 5. Now we know now it's left to right. It's not because addition comes before subtraction. It does in this case because it's to the left of subtraction. So we take this negative and positive number to add a negative and a positive. Remember, you subtract the two numbers, actually. 21 minus 3 is 18, and you keep the sign of the larger. And the larger absolute value of these two is actually a positive because it goes with the 21. So this is going to be 18. I still have the minus 5 to handle, and we know that 18 subtract 5 is 13. Now the next problem is a little bit of a thinker, okay? We've got negative 3 to the 56th power minus 3 to the 56th power. Now, notice they're very similar. Do I really want to calculate negative 3 to the 56th power before I subtract? No. If I don't have to, I certainly don't want to because that's a huge number. But here's what I know. Negative 3 to the 56th power, because 56 is an even number, is identical to positive 3 to the 56th power. Because remember, the negative raised to an even power disappears. It turns positive. So I can say that's equivalent to 3 to the 56 minus 3 to the 56. These are the same. Hey, that gives me 0 as an answer. So I was able to pull that problem off without actually calculating negative 3 to the 56 or 3 to the 56. Now the next problem, a little bit tricky. This is really important. If you'll notice all the other negative values that we raised to a power, they were all in parentheses. This 1 is not in parentheses. So what does that mean? I'm not raising the negative to the 10th power. So in this case, the negative doesn't disappear like it does in question E above. This answer down below, negative 1 to the 10th, is actually negative 1. The negative just comes over, and I calculated 1 to the 10th. Because again, the negative is not in parentheses. The only thing being raised to the 10th power is the 1. And then we have plus 1, and we know negative 1 plus 1 is 0. And that wraps up my video. So this is the end of part 2 of section 5-2, and it's actually the end of chapter 5. So next time I talk to you, we'll be talking about a new chapter, and that's going to be section 6-1. I hope you have a wonderful day, and let me know if you have any questions at all.